Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think yesterday we were discussing about the reaction of anthracene, because we have seen reaction of anthracene, that is a sulfonation. When concentrated H2SO4 in presence of acetic acid, it gives rise to the mixture of the product alpha as well as beta isomer we are getting when equivalent amount of the starting material, which is anthracene, and another one is a concentrated sulfuric acid in presence of the acetic acid used as a solvent. The resulting compound obtained, one is a alpha anthracene sulfonic acid and another one is a beta anthracene sulfonic acid. But when the excess amount of concentrated H2SO4 is used, it gives rise to the mixture of the product. One is a 1,8 disulfonic acid, another one that is 2,7 disulfonic acid. These are the mixture generally obtained when excess amount of the concentrated H2SO4 is employed or used. Now let us move on to the next reaction. Next reaction we are going to discuss, that is a halogenation reaction. That is a third reaction which we are going to discuss is halogenation reaction. We are discussing the electrophilic substitution reaction for polynuclear aromatic compound anthracene. One of them is a polynuclear aromatic compound. Now is a halogenation. Third reaction will be the halogenation. Halogenation. Third reaction is a halogenation. Anthracene reacts with Cl2 or Br2 in presence of different solvent, gives different products. Remember, anthracene reacts with Br2 or Cl2 in presence of different solvent, gives different products. Let us see here, when anthracene, as we know that 3 benzene ring fused together sharing with at least 2 carbon atom, that compound is known as anthracene. This is the structure of anthracene. This is the structure of anthracene, which has molecular formula C14H10. Number of carbon atom present in anthracene are 14 and number of hydrogen atom present in anthracene is 10. Anthracene, when it is treated with Cl2 chlorine in presence of different solvent CH2 or SO2Cl, that is SO2Cl, and when it is used, it gives rise to the product, this one. Let's see here the product which we are going to get here, this one. This is aromatic compound anthracene, and as we know that 9 position is a more reactive due to the because of resonance stabilization by sigma complex, and here chlorine atom, and here also as a chlorine atom. So two chlorine atom, they were present at 9 and 10 position. If you remember, do you remember the numbering system of anthracene, which is 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. Observe the structure carefully. What do you see here? You can see at 9 position and at 10 position, after the halogenation, after the chlorination, both the hydrogen atom, they were present at 9 and 10 position, smoothly replaced by chlorine atom and lead the product 9, 10 anthracene, that is a product, or we can say the derivative we get after the addition of this reagent, adding proper reagent and maintaining proper reaction condition, the desired product is obtained, which is 9,10 dichloroanthracene. Now, when it is treated with the alkali like NaOH, sodium hydroxide, heated after the addition of sodium hydroxide heating, one of the chlorine atom easily discarded and the product form is this one. Let us see this product. One chlorine atom still there, only one chlorine atom selectively removed from carbon number 10, and the resulting compound of 10 is known as 9-chloroanthracene, which is a product obtained in this reaction. So in this way, halogenation can be done by using this reagent. Now let us see another example, because we are discussing the reactions of anthracene. Let's see the starting material once again, anthracene, because we are discussing the topic reactions of anthracene. So you should take the starting material is anthracene. Anthracene is nothing but is a 3 benzene ring fused together by sharing 2 carbon atom to both the rings. Now when it is treated with, this is the compound which I have drawn here. Cut N, this is a Br, is a one of the very good reagent which is known as a NBS, N-bromosuccinamide. Short form is a NBS. NBS is nothing but as a N-bromosuccinamide. 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 Succinamide. N-bromosuccinamide. And this reaction can be carried out under sunlight, or can be take place under sunlight. It gives rise to the product exclusively gives this one. Let us see the product which I am writing at 9 position. Bromine atom is present, so this is known as 9-bromo-anthracene. 9-bromo-anthracene, which is a product obtained here exclusively. And now let me, and the side product or the byproduct which is obtained in this reaction would be, this is a succinamide. This is known as a succinamide. Succinamide. This is a product, side product is obtained during this reaction. So 9-bromo-anthracene will be the product obtained in this reaction. Now move on to the next reaction after the halogenation. Next reaction, we are going to discuss very famous reaction that is known as Dill-Saldar reaction. In my previous lecture, I already talked little bit about Dill-Saldar reaction. So the fourth number is Dill-Saldar reaction. Dill-Saldar reaction. Dill-Saldar reaction is one of the very famous reaction. It is known for cyclization. Dill-Saldar reaction is known as a cyclization reaction. To substrate, there is a formation of new carbon-carbon bond, and therefore synthetic point of view, Dill-Saldar reaction has big importance in synthetic organic chemistry. And Dill-Saldar reaction, cyclization reaction it is. And as I already told you in the simplest reaction, and that Dill-Saldar reaction smoothly carried out at room temperature, it is a thermally allowed reaction. Temperature just 25 degrees centigrade, or it is a thermally allowed. There is a triangle in a photochemical or in a pericyclic reaction. There some of the characteristic of that pericyclic reaction. Pericyclic means electron are moving in a one direction, either clockwise manner or counterclockwise manner, and there is a formation of rings. That reaction are concerted reaction. Concerted reaction means what? The breaking and forming of bond taking place simultaneously, just like SN2 reaction. SN2 reaction is a concerted reaction. In that reaction, breaking of bond and forming of bond takes place simultaneously. So that kind of the reaction generally termed as concerted reaction. So pericyclic reactions are generally concerted reaction because bond forming and bond breaking takes place simultaneously. In Dill-Sulder reaction, speciality of that Dill-Sulder reaction that are thermally allowed reaction, which is also known as 4+2 cycloaddition reaction. 4+2 means the 4 is nothing but as a reaction taking place between as a 4 pi bond electrons, and 2 pi means 2 pi by electrons, and that suprafacial if you talk about the orbitals, the same phases overlapping beautifully. And another important characteristic of that Dill-Sulder reaction, it requires a diene and the dienophile. If diene has electron releasing group or electron donating group, and dienophile which has electron withdrawing group, the cycloaddition reaction or Dill-Sulder reaction, rate of that reaction is increases in many fold than the normal diene and the dienophile. In diene means alternative carbon-carbon double bond, and that diene must be in a cis form. Then and then Dill-Sulder reaction takes place or occur if there is a trans diene there is a no Dill-Sulder reaction occur. It does not occur Dill-Sulder reaction. The reason behind it, in trans two end of the diene are, I think 3.4 angstrom something is there, and for reaction to occur according to van der Waals force of attraction, the two end must have the distance 2.4 angstrom, then and then orbital can approach and overlapping takes place with the same phases, and we are getting as a cyclic reaction. So that type of the reaction is known as a Dill-Sulder reaction. And in case of cyclic compound, diene are always present in the cis form, and therefore the rate of reaction is tremendously increased in that particular reaction. Anthracene easily undergoes cyclization reaction, giving mainly 4+2 addition product by heating with malic anhydride. Addition occur at 9 and 10 position. Let's see over here once again. Here I am showing the structure of starting material, which is anthracene. Here it will be react with, this is a structure which I have drawn over here, is nothing but as a succinic anhydride, is known as a succinic anhydride, succinic anhydride, and the name of this compound is a anthracene, and this is a succinic anhydride. This reaction takes place at thermally allowed reaction, that is a cyclization reaction takes place, and this reaction occur at 9 and 10 position, and the product formed will be this one. I am showing one benzene ring this way, then another benzene ring I am showing here like this, and there will be this is a compound which I am showing over here. This one C double bond O, this one. This is a compound. Cycloaddition reaction takes place over here. We are getting as this type of the compound. At 9, this is the 9 position, this will be the 10 position. How beautifully reactions occur, and the product form will be 9,10 dihydroanthracene, 9,10 dihydroanthracene, 9,10 alpha beta succinic anhydride, 9,10 alpha beta succinic anhydride, succinic anhydride. This is a product. This is known as a Dill-Saldar reaction. This is an addition reaction which is occur in case of that anthracene and the malic anhydride. Let us move on to the next reaction, which is also known as oxidation reaction. Fifth reaction is nothing but as a oxidation reaction. Fifth reaction is a oxidation reaction. Fifth reaction is nothing but as a oxidation reaction. Oxidation reaction. Oxidation reaction. Anthracene on oxidation with various oxidizing agents gives 9,10 anthraquinone. That is a very simple reaction for oxidation. So here generally there are various oxidizing reagents commercially available in the market, and very easily available is a chromium trioxide. Oxidation reaction occurs with CrO3, chromium trioxide, one of the strong oxidizing reagent, but oxidation takes place at 9 and 10 position. It gives rise to diketone, so anthraquinone you can call it. Simply, this is a quinone structure, as we know that this type of the structure generally gives over here. This is a anthraquinone. Anthraquinone. This is a structure obtained during this oxidation reaction. So in this way we have discussed so far halogenation reaction, Dill-Saldar reaction, oxidation reaction. In our next lecture we will discuss the remaining reaction. One is a Friedel-Crafts alkylation reaction and another one is a Friedel-Crafts acylation reaction. I think that are the reaction we will we will look in our next lecture. I think with this, let us stop today here. Remaining reaction we will discuss in our upcoming lectures. Till then, have a nice day. Thank you.